name is Chelsea Carpenter, and I am going to be a freshman at Bridgewater State University. I'm going to be majoring in anthropology and history. I'd like to thank the audience for watching my video this morning. Here we go. If you're a homeowner, you've probably dealt with an ant infestation at one point or another. You probably associate these insects as pests or perhaps insignificant. But what if I told you otherwise? What if I told you that there's a long and fascinating evolutionary history behind these peculiar insects that dates back all the way to the Cretaceous period? But how do you figure out the evolutionary change of ants from the Cretaceous period all the way to the present? Carl Zimmer, author of New York Times' Heated Ants Evolution, claimed that scientists first started searching for the origin of ants by looking at the structure of their bodies through 100-million-year-old fossils. Those scientists came up with a thesis that ants were closely related to wasps and bees, all part of the Formicidae genus. To figure out the evolutionary change, we must understand the morphology of the oldest prehistoric ant shown in the above diagram here, the Pachycondyla vernae. They can be most easily identified with the following characters: mandibles triangular, interior clypeal, margin without projecting teeth, mid-snoddle groove at most present suture, a slit-shaped propedial spherical, metapleural gland orifice with a posterior U-shaped lip, an areola not prominent, and unarmed claws. A thick block-like node of pedicellate striatum, absent of pterygoid of A4, and a hypopium with a row of stout spines on either side of the sting. Pachycondylas are most likely to be confused with Dinopaneras, Neopaneras, Ectomomorex, or the Bothroponera, all different breeds of the prehistoric insect from the same Formicidae genus. Like the Dinopanera having smaller body and mandibles, the Neopanera lacking a striatum, and on the pterygoid of A4, from the Ectomomorex and its complex metapleural gland orifice, and from the Bothropia and its hypogenical spines. In the 1990s, Dr. Ward and his colleagues from the University of California conducted a study by sequencing genes from other insects to gather more evidence of evolutionary change. But for years, a clear answer remained elusive. However, Dr. Ward's recent research of 2013 had him take advantage of the explosion of DNA, searching for power to take a fresh look at the problem of ants. Dr. Ward traveled to California and Nevada to catch ants, wasps, and bees. His team sequenced more than 300 genes from one species of ant to 10 species of bees and wasps, each representing a major lineage. The scientists then used computer research for an evolutionary change tree that best accounted for their genetic data. Dr. Ward's team came up with a conclusion that their research clearly pointed to a mud dauber wasp as the ant's closest cousin. So, what's the secret behind the evolutionary success? Well, during the Paleozoic period, when Earth's continents clumped together to form Eurasia and Gondwana, that's when prehistoric ant species began to diversify. As these continents continued drifting, they've experienced climate change based on migrating locations, such as mountain building and volcanic activity. Through all these continental and climate shifts, ants managed to thrive and survive. Ants have colonized nearly every landmass on Earth, with the exception of Antarctica. As of today, scientists have identified more than 12,500 species of ants, but claim that there's perhaps 10,000 more in store for discovery. In conclusion, and the ant being the most dominant insect on Earth, has a long and complicated and interesting story in their genetic buildup and DNA. One can imagine that the Formicidae had not evolved, and so the present period will be perceived as a modest group of tropical wingless wasps, as opposed to the near ubiquitous urological dominance we know of today. But then again, perhaps another poneroid would have stepped in to fill the void. My web source was wiki/ant and expeditions.fieldmuseum. My book source was New York Times, Key to Ants Evolution by Carl Zimmer, and The Lives of Ants by Lauren Keller. Thank you.